right? And that's your final answer. So the correct answer would be E. Okay. So now you guys can attempt the first way as well and see what you get, right? But all we can do it, I think we can just go through it as well. So we can use that as a practice for integrals. So when you take the integral of x over x squared plus 1. So a trick that you can use here, right? A trick that you can use when you have, and I think it might be mentioned in your notes somewhere, when you have the integral of one polynomial divided by another polynomial, and the polynomial that is in the numerator is of 1 degree lower than the polynomial that is in the denominator, then you can use, right? You can already tell from that alone that your solution will have some ln, right? So that's a trick that you guys can already tell, because remember, when we have ln of x, if you go back to what we're doing when we're looking at ln, so if you have ln of x, sorry, ln of f of x, let's take the general form. If you have ln of f of x and you're taking the derivative of that, again, this just comes with practice. The more you do it, the more you see this. When you take the derivative of ln of f of x, this is just equal to the derivative of f of x divided by f of x, right? And you can already think about it. If f of x is a polynomial of, let's say, degree 5, in the denominator here, you will have the same degree, the polynomial of degree 5, but when you take the derivative in the numerator, it will be 1 degree lower, right? So let's say if in the polynomial you had x to the 5, you take the derivative in the numerator, you'll have x to the 4, right? So that's sort of something that you can, an intuitive way you guys can use to already tell that if you have an integral like this, you might have some ln involved there. It just so happens that our case is a bit easier because we have that if you derive the denominator here that we have 2x, right? But in the numerator we only have x. So all you have to do is just then divide your ln in the solution by 2, such that, so I'm just going through this quickly because we'll cover integrals in the future sessions, but it's just sort of an intuitive, sorry, a quick method you can use to solve this. And you can quickly see that if you divide by 2, when you take the derivative of the x squared plus 1, you'll get 2x, and then the 2x will just simplify with the 2 there, and then you'll be left with the x that we see in the numerator there. And obviously, when you take the derivative of the plus 1, it will just disappear because the derivative of the constant is equal to 0, right? So this is what we have. Obviously, it's plus c, which is our constant of integration. Although I don't think we really need it here. So for now, we can just ignore the constant of integration and just take the function as it is. And then since we already have f of x now, we can substitute g of x into it, right? We substitute g of x into it. And what we have now, f of g of x we have that f of g of x is equal to, if we copy ln there, so it will be ln of the square roots, right? The square root of 3x minus 1 all squared plus 1, right? All divided by 2. And this is obviously equal to, right? If you simplify this is equal to, this square there will just be equal to 3x minus 1. And this will be equal to ln, right? So ln of 3x numerator divided by 2, right? So that's your f of g of x. And then you're looking for, and that's your big f of x, right? Remember, that's your big f of x, right? So when you take the derivative of that now, right, which is what you're looking for, you will have the derivative of ln 3x is just 3. Well, it's basically 1 over x, right? It's 1 over x. And then it's multiplied by the 1 over 2 there, right? Because so it's basically 1 over 2x here, which is our original answer as well, right? So you end up getting the same solution. So for a question like this, it really is up to you. It depends on what method you want to use, but preferably you would want a method that doesn't take you long. So you just use whatever method you see fit, right? So moving on to question 6. So for question 6, we have a limit. So this one is a bit tricky. So you have a limit such that as x tends to 0, f of x over sine of x is equal to 4, right? So now, and you are asked to find the limit of f of x. So since this is a MCQ question, you can already see from what the question tells you already. You can already see which one of the options is not correct. And option B obviously is not correct. You know why? Because they've already told you in the question that the limit does exist. It's equal to 4. So whatever the limit of f of x is, right? It does exist because when you derive that limit with the limit of sine, as x tends to 0, you get 4. The question already tells you that. So option B is not even something that you have to consider, right? So it's already out. So now let's look at the actual question and think about it. So here you need to think a little. So if you think about it, you have that as the limits, as x tends to 0, f of x over sine of x is basically just f of 0. If you substitute in the value of 0, f of 0 over sine of 0, sorry, right? And that is just basically equal to f of 0 over 0, right? I think we're together up to this point. Now, if you guys remember, they didn't tell you anything else about f of x, right? No restrictions or anything like that, so you can make assumptions. The first assumption you can make is, well, this, if you remember your limits, this is looking like the limits of 0 over 0. Sorry, this is looking like 0 over 0 when we're looking at limits, which is a case where you would apply L'Hopital's rule, right? So we can, one of the assumptions that we can make is that f of x is equal to 0 as well. Because if f of x is equal to 0, then you would have 0 over 0, such that you can then use L'Hopital's rule and derive the numerator separately, divide that by the derivative of the denominator, which it will become cos. And then when you substitute the x value into those derivatives, you'll just get the 4 that is given to you, because they've already told you that the limit does exist. Okay, so whatever f of x is equal to, it needs to be equal to something that can just help you manipulate the expression to find the limit that is equal to 4. And the assumption that we make is that when you substitute 0 into f of x, it's equal to 0 as well. So that you would get this entire limit here be equal to 0 over 0. Okay, so just follow my thinking here. Yeah?
You know the rule that limit of as x approaches 0 or infinity, I'm not sure, of sine x over x is equal to 1, right?
Yes, exactly. Yes.
Do we also
So
have, yeah?
that is one of the that is one, well, it really is the same, because if you think about it, that rule comes from L'Hopital's rule.
Oh, okay.
Think about it. So if you have the limit as x, so you're saying sine x over sine x or sine x over x, right?
That, I'm gonna go to
when you
that.
substitute, you have 0 over 0, right? Which is a case where you can apply L'Hopital's rule. So when you do apply L'Hopital's rule, you'll take the derivative of the numerator and the derivative of the denominator, right? So let's substitute that. When you use L'Hopital's rule, the derivative of x is just 1, and the derivative of sine x is cos x.
Yes.
Right?
Yes.
Which then means that when you substitute 0 into that, you'll have 1 over 1, which is equal to 1. So that's where that rule comes from. I'm not sure if you guys knew this.
Thank you.
Yeah, so that's where the rule comes from. So it basically is a version of what we will be doing here. So now that you mentioned this, you can already also see that it's sort of a quicker way to think about this. So if you already know this rule, right? I didn't want to use this rule, but we can use it as well. So if you already know that the limit as x tends to 0 of x over sine of x is equal to 1, what would you need to change this one into 4? Think about it. Because in our limit, we have a 4 there. So what would you need to do?
Multiply by 4.
Right. So another way you can think about this is, which is basically where we're going, but you can think about this as well like this. So if you already know that this is the rule that is given to you, right? Which was derived, as I said, from L'Hopital's rule. You already know that, then you can multiply it by 4 on both sides. Okay, you're allowed to do that. And then, obviously, since 4 is a constant, it can come in and out of the limits, right? So if you take the 4 inside the limit, take it from outside, you bring it to the numerator there, then you have the limit as x tends to 0 of 4x over sine x, right? Which, if you compare it to our original question, right? If you compare it to what we originally had, then you have that your f of x has to be equal to 4x, right? Hopefully you guys are following this, because remember the rule for two fractions to be equal, right? You need to have the numerators equal and the denominators equal. Yes, yes.
I'm not following. I got lost. You said there's a rule that Snetamba mentioned,
Yes,
which is equal to 1.
yes,
Where
this one.
above that we derived there was an indeterminate form, and
Yes.
then we use
Okay, this is a
L'Hopital's.
yes. Okay, we can keep going from that, but I just wanted to use the rule that she mentioned to show you that we get to the same answer. So let's just say that we used the rule that she mentioned. We get to f of x be equal to 0, to, sorry, to 4x, right? But if you go back to the original way we were looking at it, right? We said that we assume that f of x is equal, f of 0 is equal to 0, right? Such that we would have 0 over 0 to apply L'Hopital's rule. Okay?
Yes.
Okay, so if you followed with the same logic, if we apply L'Hopital's rule to this case, right? Then we have, right, in the numerator, the derivative of f of x divided by the derivative of the denominator, which is just cos of x, right? You follow me until this?
Yeah.
Okay, so now if you substitute 0 into that, right? If you substitute 0 into that, then you get in the numerator f prime of 0, yes? And that is divided by cos of 0, which is just 1, right? I hope this is making sense up to this point.
Yeah, it's making sense.
Right, so now up to this point, since you know this will just be equal, because you're dividing f prime by 1, it will just be equal to f prime of 0, right? And from the original question they gave you, that this limit was equal to 4, right? So you can just equate this to 4.
Okay.
So now if you go about it, right, and think about it, if you have f prime of 0 is equal to 4, if you have f prime of 0 is equal to 4, now that's where you have to use some thinking. Which function would this apply to? Obviously, you guys know it's 4x because we've already done it. But if you think about it, you would first have to find a function that you can derive. When you derive it, then you substitute 0 into it and you find 4. Right? And that function, if you can, based on what we've done in the second, that function will have to be f of x is equal to sorry, f of x is equal to 4x, because when you derive f of x, right, when you take the derivative of, when you take the derivative of f of x, you have that is equal to 4, right? And when you substitute 0 into that, right, when you substitute 0 into that, you just have that it's equal to 4, stays 4, because there's no term in x, right?
Okay.
Okay, yeah. Hopefully this makes sense, guys. I'll upload this file as well, so you guys can go through what we did once more. So moving on to question 7. Right. Just give me a minute to check on something. See, we're running out of time. So this might be the last question that we cover. Okay, so Just give me a minute, guys. Yes. So we're looking at question 7, which is asking us to find the critical points for f of x equal to x squared over x squared minus 4. So now this is theory. So what, guys, how do you find the critical points of a function?
I think we solve for x.
Sorry?
Derivative.
Solving for x.
Now find the derivative.
So you find the derivative, and then what? What do you do with the derivative?
Equate to 0.
So you're basically finding the values of x for which the derivative of f of x is equal to 0, right? So let's do that. First, we'll need to find the derivative of f of x, right? Which we'll need to use the quotient rule for this. So remember, when you have f of x is equal to x squared over x squared minus 4, and you're trying to find to use the quotient rule to find this derivative, you take the derivative of the numerator, right? You multiply that by the denominator minus the numerator multiplied by the derivative of the denominator, right? And all of that divided by the denominator squared. So if you guys go back to your quotient rule for derivatives, you'll notice that that is what the rule says. So when you derive the numerator, you have that it's equal to the derivative of x squared is just 2x, right? So it's 2x multiplied by x squared minus 4 minus x squared multiplied by the derivative of x squared minus 4, which is just 2x, right? All divided by x squared minus 4 squared, right? Yeah. And then we can simplify the numerator. You'll have that 2x cubed, right, minus 8x minus 2x cubed divided by x squared minus 4 all squared, right? And this is equal to the 2x squared will cancel, right? So you'll be left with the negative 8x divided by x squared minus 4 squared, right? So that's the derivative of your f of x, right? And now, for our critical points, right? We can clearly see that for the numerator, we have one critical point there, and that is when x is equal to 0. Because for this entire function to be equal to It just means that x squared minus 4 is equal to 0. And this is only the case when x squared is equal to 4, which is only the case when x is equal to plus or minus 2. I hope you guys can see this. So we have 3 critical points. We have 0, we have minus 2 and plus 2, right? So our answer would be B here. Okay, so yes, that will end it here since we're out of time. You guys can keep going for question 8 and question 9. And then you can just see if you're able to solve them, right?